Okay, so there's one more question from this. No, not one more, two more questions from this. This question is very interesting. The question is that if Q, please mute yourself, P, Q, R are positive integers, such that Q is a multiple of P and R is a multiple of P. R is a factor, not multiple. R is a factor of P. Then the question is, which of the following is not an integer? I'm repeating the question. If P, Q, and R are positive integers such that Q is a multiple of P and R is a factor of P, the question states which of the following is not an integer? Quantity A is Q minus P over P. Quantity B is, option B is Q minus P over R. Option C is Q minus R over P. Option D is Q minus Q into P square divided by R, and option E is Q plus PR divided by P. I'm repeating the question. If P, Q, and R are the positive integers such that Q is a multiple of P and R is a factor of P, which of the following is not an integer? The options are Q minus P over P, Q minus P over R, Q minus R over P, Q into P square over R, and Q plus PR over P.
C.
C. Okay. Solve this question. We'll discuss. Take 2 minutes to solve this question.
So answer should be one of these answers, or not enough information can also be an answer?
One of these.
So I'm asking this because R is definitely less than P is not said here, right? So it can be equal to P as well.
Consider this is as a must not case. Which of the following must not be an integer? Now try this question.
C. The answer is C.
Answer is C, I think.
I guess so. Answer is C.
Anyone else?
I guess so.
Wait, let others solve, then we will discuss. Okay, let's solve this question. Yes, the answer is C. Now let's see how the answer is C. Again, there are multiple approaches to solve this question. One is by assuming values, but in such case, you may have to check more than one value. So in such cases, it is better idea to use the algebraic to use this in form of expressions. For example, the question is saying that P, Q, and R are positive integer such that Q is a multiple of P and R is a factor of P, right? We have Q, P, and R. Q is a multiple of P, right? And R is a factor of P, right? We can write that as Q is a multiple of P. Can we write this as Q is equal to Px, where x is an integer,
Yes.
and
Hello.
is a factor of P? Can we write this as P is equal to R into Y, where y is integer? Yes or no? Yes.
Yeah. Yes.
Yes.
Now try to use these in solving. Okay. What is option A? Option A is Q minus P by P. By substituting this, Q is equal to Px and keeping P is as it is, and this is P. If we divide it, we will come it with x minus 1, right? So this could be an integer. Take any value of x, 2, 3, 4, up to so on, it will be an integer. So this is not a possible case, right?
Yeah.
The next one is we have Q minus P over R. Q is equal to Px and P is equal to Ry, and our R, P is equal to Ry. This will be Rxy minus Ry over R. This is equal to xy minus y. And this could be integer as well. Yes or no? Take some values, you will get this as integer.
Yes. It will be that will be integer.
Now let's move to the D first. D is Q P square divided by R. Q is equal to Px and P is equal to Ry divided by R. Actually, P is equal to x Ry plus into Ry square divided by R will cancel out and you will get some integer value. So this is not possible answer as well. And now move to the E part. E part is Q plus PR divided by P. Q is equal to Px and PR divided by P. Again, you will get an integer. P will cancel out, you will get an integer value. This is again not possible. Now moving to the C. C is Q minus R over P, right? So what is Q? Q is Px minus R and P is equal to Ry. Let's keep this P for now. So this will be equal to x minus R by P. And as P is equal to Ry, this is R over Ry cancel out. So this will be x minus 1 by y. And what we said earlier that x is an integer, this is a fraction. So integer minus fraction can never be an integer value. Anyone got this?
Yes. Got
Yeah,
you.
got it.
Got you.
This is a very quick way to solve this. If you start using the sum by assuming some values, you need to check because this is must question. If this is could be question, you can check that way. But this is must question. In must type question, all of the condition must be satisfied. So you, in such cases, if you start assuming values, you will check for 1, 2, or 3 values, and that will take your time. So in such question, try to come up with algebraic or equation type And just like in this way, we have x minus 1 over y. This is integer and this is fraction. Integer minus fraction can never be integer value. So this is our answer. And C is only in which there is no integer value. Right?
I think I have a little bit confusion over here.
Yes.
I have done slight differently regarding this. I have supposed, as per the question, I have supposed P by Q is equal to integer 1, while P by R is equal to integer 2, as given in the text. I have multiplied both
Listen,
P by Q.
wait. So what you did?
Q by P is equal to I1. As you supposed, I have supposed Q by P is equal to integer 1. And P by R is equal to integer 2 as given in the question.
And P by R is
Integer
equal to
2.
integer 2.
Integer 2. I have
I1,
calculated.
I2.
Yeah. I have calculated the supposed value I1 and I2 in equals to
Listen,
side, and
this is, you are exactly doing same thing. You are in this state assuming, which I assume X, you are assuming that 1. And which I assume
Yes,
Y,
Y.
you are assuming that 2.
but I have calculated I1 into I2. That is Q by R value over here.
What you did? Subin, I'm
Yes,
not getting
Q
what
by
you
R.
are saying.
And
Okay, you are
if you
saying Q by
multiply,
P. You are saying Q by P minus R by P.
no.
And
Q by
Q by
P
P
into
is 1.
P by
Into
Q. Into, not minus, not
I have
subtract.
calculated the value of Q by R over here. That is I1 into I2.
If you multiply I1 into I2, you will get Q by R.
Q by R.
So R Q by R, yes.
Yeah, I have done by this method.
There are multiple ways. There are even more than these to solve this question. You can even do this way, that if I assume this is 1, this is 2. So this will be Q by P minus R by P. And we are given this value. So you can just take 1 and 1 over 2 here. You will also get this non-integer. But the point is, try to come up with such method that you can use everywhere in most of the question. Okay. So
Okay, got it. Thank you.
perfect. So till now you must be a bit familiar with the factors and multiples, right? Let me throw at you a bit difficult question. This must be last question for today. And the question is, if X and Y are integers and 12x plus 5y square is equal to 0. The question says, which of the following must be true? The options are x is a multiple of 10, x is a multiple of 15, x is a multiple of 25, x is not a multiple of 7, and x is a negative. X is negative. I will repeat the question. The question is saying that if x and y are integers and 12x plus 5y square is equal to 0. So question is saying, which of the following must be true? So A is saying that x is a multiple of 10, B is x is a multiple of 15, C is x is a multiple of 25, D is
X is negative.
x is not a multiple of 7, and last one is x is negative.
I think X must be
X is
negative over
negative.
here.
X must be
Multiple of
negative.
15. Multiple of
Y
15.
square can't be negative here.
Listen, this is not that much easy question. Take your time. take at least 2 minutes to try to solve this question. Then we will discuss about it.
How many options? I mean, only one answer can we choose?
Only one answer.
Is it homework or you will give the answer now?
Solve this right now.
I think the answer is A.
The answer is B.
Okay, so is anyone able to solve this question?
Yeah, B.
No.
Anyone else? So we have B. Only B. No other answer for now. Okay, so the answer.
Integer, is it include 0 as integer?
Yes, that's why E is not a possible answer.
Is not possible, that's why. Yes.
Right, you got my point. Okay, now in this question we are given that X and Y are integers, right? And the situation is 12x plus 5y square is equal to 0. And if I move 12x on the other side, that will be 5y square. 12x is equal to minus 5y square, right? And if I do the prime factorization of 12, that will be 4 into 3 is 12, right? So 4 is 2 square, 2 square into 3 into x is equal to 5y square. Now we can easily negate E and D, because if as both are integers, if x is 0, y is 0, the condition is satisfied and the question is saying must be true. That's why E is not possible. X is not a multiple of 7. We cannot also say that. Just by considering X is equal to 0 and Y equal to 0, we can straightforward remove D and E from our chart. Now the trick is, the actual point we need to think is, we have 2 square into
We have to
3.
factorize all the multiple.
Yeah. Just hold for a second. We have minus 5 y square. Now see, we have 2 square. We have a square term. And in this, we have square term. So 2 square can move inside of y square. Right? First point. Second point is, we have 3. But on the right side, we have minus 5 into y square. So 3 must be lie inside of y square. And in question, it is said that y is an integer, right? So inside of that, there must be 3 square, right? So there should be at least 1 3 in this. So X contain at least 1 3. Now there is 5 on right side. To accommodate 5 on left side, there must be 5 inside of X. So X must be at least containing 5 and 3. So it must be a multiple of 15.
Could you please repeat for the second term? Y for the term of Y?
Which point?
How you will get Y?
Listen,
3
listen,
include Y square.
listen. We have, kindly mute yourself. We have 2 square on the left, and you know that equality rule is the right term must be equal to left term, right? So there must equal 2 square on right side to accommodate this. So we have minus 5 and y square. So this square value must accommodate in y square. So let's suppose we are just done with y square for now, for 2 square for now. We are left with 3x and minus 5y square. But we have 3 on the left side, and we must also have 3 on the right side. But on the right side, we have integer square, right? So it must contain at least, if y is 3 or multiple of 3, it must be a square of 3, right? So accommodate 3 square, there must be at least 1 more 3 in X. That's why we will have 3 square in this and 3 square in this. So X is, first point, X is a multiple of 3. Now we have 5 on right side. To accommodate 5 on left side, there must be 1 5 at least in X.
Left side, yes. Left side.
So X must contain at least 5 or 3.
At least 5.
So it must be a multiple of 15. Now we have 2 other options, A and A10. So, but we have only, this is must case, right? But if we consider this, we have y square and 2 square. 2 square will accommodate in y square. There is no extra 2. There could be a case we can consider extra 2, but there is no must case. So this is also removed from our chart. And the last one, it is a multiple of 25. That is only possible if we have
2 5. 5 square.
5 square outside. We could consider a case, but that will not be a must case. You got my point?
I got you. Yes, I got you.
Perfect. Anyone else got my point?
Yes. Why you treated E option? Can you repeat?
Reason is because because X and Y are integers. So if I consider X and 0 and Y and 0, our condition is satisfied. You got my point? The question is saying must be true. So any one of you might argue that, then what about B? X is a multiple of 15. Whatever the value is, 0 is multiple of every value. So that condition also satisfied here. Got my point?
Okay.
Okay, so today we have done multiple questions from factors and multiples. These are very good questions, and you try to solve again all of these 3-4 questions and try to solve this logically. And if you are able to solve these logically, you can solve any type of multiples and factors question. there are many more things to come in multiples and factors. We will discuss these when we discuss the prime factorization, and then we'll proceed to this. Afterward, consecutive integers, consecutive even and odd integers, right? So I hope that today's session is helpful for you.
Yes.
Yes, this session was very helpful.
Okay, so you start solving from any resource.
No homework
Not
for
at-
today.
Not
No
at all.
homework.
No, I want this to give. I earlier want this to give you homework, but we have already discussed this. We will have a sort of quiz once we are done. We are a bit ahead because right now we are too much late and there are so
Can
many
you
things to be
give?
covered.
I have a suggestion.
Yes.
Can you give some? I mean, daily 10 questions for practice for us.
Yes,
Can
that
you?
will be just a fine solutions, I think. If you give us some questions like that, we can.
See, I will try from the next class to come up with some questions.
Okay, that will
It will
be
be
fine.
better option. But still try
Okay.
to, whatever resource you are using, try to implement these strategies and concept which we are discussing.
Yes.
Okay, so no question for now? Okay,
No,
I
sir.
will, perfect. I will upload the recording in the channel. You can watch that afterward. And
Can we change slightly our time period regarding the class?
I am available only in this time period or in the early morning. That will be too early
Since
for you in the case. Well, let's see. We will try to have a flexible timing, different timing, not any specific timing for. But let's
it's
see.
nearly midnight in my place.
From where you belong?
I'm from Nepal.
Nepal. What is the tea time at your place?
It's a 45-minute earlier. It's 5.45 hours. I think 45 minutes early than yes, IST. 15 minutes than IST, I think. It's now 23:53 means it's 11:53 right now here.
Okay, anyone of you from Pakistan or from India?
Yeah,
Yes, from Pakistan.
11:50.
I'm from India.
So we have a
From Bangladesh.
diversity of people, right?
I'm not from Nigeria.
Yeah, some people are from Africa as well, Nigeria.
Yes, Nigeria.
Perfect. So I believe these sessions are very helpful for you guys.
Sure,
Yes,
sure.
thank
Yeah.
you so much.
Sure,
They are
sure.
very helpful.
It's very helpful for us.
Perfect then. So tomorrow we will discuss about the consecutive.
Where are you from?
Read about those. I'm from Pakistan. Just read about the consecutive integers and prime factorization, how to find number of factors, and let's try. Okay then. See you.
Tomorrow also same time, right?
I will convey in the group, and if I'm unable to convey that, the time will be same. And in either case, the time will change. I will convey in the group, and if I'm not conveying this, that means the time is same, right? Okay then. Bye bye.
You'll be notified, right?
Bye.
Yeah.
Thank you.
Perfect. Bye bye.